Tell us your name and tell us about your project.
My name is Logan McAfee, and I worked with Albert Michelson on an experiment to try and find the evidence of a medium for light waves to propagate.
What were you guys trying to do or find?
We were trying to prove the existence of a medium that light waves travel through. Previous physicists called this medium the ether. And so we set up our contraption, we called the interferometer, and our idea was if we could shoot a beam of light parallel to the path of the ether, and if we could hit a beam splitter that was at a 45-degree angle, then we could split that light beam up into two separate light beams going at 90-degree angles to each other. And then they're going to hit mirrors that are equal distance from the beam splitter. And whenever they come back down, they will travel to a light detector. And if that light hits that light detector in phase, like it started, then those lights were traveling at the same speed. But if they were out of phase, then those lights were traveling at different speeds. And if those lights were traveling at different speeds, then we know that there was a medium that affected it. But after our test, the lights come back in phase every time with very little variation.
Where did the experiment occur?
The experiment occurred in Cleveland, Ohio in 1887 at the Case Western Reserve University.
What other significant events were happening around the world at this time?
The photoelectric effect was discovered by Heinrich Hertz, and also that was discovered the same year that we started our experiment, and also Erwin Schrödinger, who's a famous physicist known for his works in quantum mechanics, was born in 1887 as well.
Who else was involved in the project?
Our co-worker, Edward Morley, helped us in planning the construction of the interferometer.
What was your role in the project?
I worked with the calibration and setting up of the interferometer.
What impact did your project have on the physics community?
Well, we sent our results to a famous physicist, Lord Rayleigh. He rejected our findings. He stated that the Earth actually dragged the ether, so we would have to account for much less ether. And so our results would be a lot smaller than we were expecting. And so what we did is we added more mirrors in, and we increased the travel distance of that light beam by a factor of 10. And so that greatly improved our accuracy. But even after we did that, there was little to no change in the results.
What was one of the hardest parts of the experiment?
One of the hardest parts of the experiment was keeping the machine calibrated and minimalizing vibrations from the environment around us.